Hello everyone. So this is the project that is a part of my internship. So this is the dataset that we have. That is, we loaded the dataset. It is regarding the predicting the presence of breast cancer in human. So here's the data set that we have loaded from sklearn, and after that this is the data set that we printed. It is in the form of an array, so we need to convert it to a data frame. So here is it. I use p.data frame for that, and then showing here of this, and we are joining this label or the target variable to this data frame. After that it looks like this, so you can say it is showing that 000 and 1. It has 569 rows and 31 columns, where one column is a target variable. After that, here's a data frame info. As we can see, all our float values 569 all, and no null value columns. After it is a sum of no null values column, and after that it is void describe. So see how the statistically how it looks. It looks pretty well. Uh, then again, there is value counts, like how the different kinds of uh, predictions are distributed. So it is not so much in varying. It is normal. It's no problem. Then again, going now we are separating the features that are target variable and the whole data frame, so that we can do the model building process. So we have done drop columns x1, and this second is uh, taken as the label. Here's the data frame. Here's the y thing, and spreading the data into training data and testing data. So did this train test spread? So here is different shapes of all the things that we want. Here we have used standard scalar. So this is initialize the standard scalar, then fit transform, then transform on the test set. Now we'll do some building the neural network part, importing the necessary libraries, and then this is the model building step, that is you are creating a keras sequential model with the input shape 30, like 30 is because there are 30 variables that we are taking. This is the input shape we have, and then we in the next layer we did some normal ReLU activation function, and again we have a sigmoid function because it is kind of a binary classification. So sigmoid is good for binary classification. This is for compiling the neural network. We used Atom as optimizer, sparse categorical crossing topic as a loss, and metrics for accuracy. So here's a history of how you can see that what kind of accuracy we are getting. So it is pretty good. Accuracy is 0.9584. 95% accuracy is good. Here we did some plot of our project accuracies. This is the loss function, the model loss that we have seen that over the epoch. Different we are decreasing the model losses, so that is good. So here we predict on our test set, like X test, we got the Y prediction. So this is what we got Y prediction. It is kind of, if you see, it's kind of a probability of that particular prediction, different classes prediction probability of each class for that point. Uh, so this is how the, so here we have converted the prediction probability to class labels. Then we are building the predictive system. So as an interface, how we can use this project, that will do some HTML forms or any web interface forms. You can create APIs for that in any of Express.js or Flask, and you can extract the data, and then you can give the data to this model. And now again, input data will be this kind of data that we have extracted from the form, and then you give it and you predict the prediction, and according to the prediction that you get, you give the output that a tumor is malignant or tumor is benign. So this is how the whole project looks like. I hope you got it, and I hope I made this project very well.